So just before we get truly started, let's just recall what happens here if we consider x given w equals w. So in the gamma distribution, the mean value is given as the product of the first parameter and the second parameter inverse. So the mean of x given that w takes on a certain value is equal to alpha divided by 1 over w, so alpha w, whereas the variance of x conditioned on w given equals w is alpha multiplied by w squared. And this is based on the formulas that we have in the book for the mean and variance in a gamma distribution. So what do we need now? What we want to do now is we want to find the mean value of x. And the mean value of x is, using iterated expectation, equal to the expected value of the conditional expectation of x given w. And we've already established this here, that given a certain value of w, the mean of x is alpha w, which means that we can just substitute the alpha capital W inside here. And the reason we can do that was based on these arguments that we made earlier. So just go back to the previous video and review them again if you forgot it. But just in general, this is something that we can just do. So here we can take the alpha constant outside, and then I have the mean of W inside here. And what again is the mean of w? Well, w is exponentially distributed with parameter lambda, so that means that it has expected value 1 over lambda. So in conclusion, the mean of x is alpha divided by lambda. Now, what is the variance of x? Well, the variance of x is given by this thing here. So we have the variance of the mean of x given w plus the expected value of the variance of x given w. This is a capital W, by the way. And what do we have? Well, the mean of x given w is alpha w. So here we have the variance of alpha multiplied by capital W plus the expected value of the variance of x given w, which is alpha multiplied by w squared. And here I can take the alpha outside of the variance, then I have to remember to square it. Then I have the variance of capital W here. And then after that, we have the alpha outside and the mean of w squared here. And this is fortunately quite easy to calculate, so you can just find these values in the book. I think that in the book you can find the moments of an exponentially distributed random variable, and based on that you can find the variance using the definition of the variance, and what we get as a result is 2 alpha plus alpha squared divided by lambda squared. So just do these calculations on your own and check that they are the same as what I get here.